Hi everyone, welcome back to Lifey Technologies YouTube channel and thank you for watching. So this is a continuation of our Nokia lab simulations, and in this episode we'll be discussing how you can import or export routes in BGP. So in our last episode we discussed how to configure BGP on Nokia routing devices, and we are building up on the same lab simulation. You can see from this topology we have two autonomous systems. We have R1 and R2 in a 65500, and we have R3 and R4 in a 65501. So we did configure BGP peering session, both IBGP session and eBGP peering session. So in a 65500 we configure IBGP peering session between R1 and R2, and in a 65501 we also configure IBGP peering session between R3 and R4, and then we configure eBGP peering session between R2 and R3, which are in different autonomous systems. We also demonstrated how to configure BGP groups that will help us to simplify the configuration, and also it reduces the number of commands, especially when you have so many peering sessions and you need to run repetitive commands. So we can verify that our peering sessions are up and also check the BGP configuration that we did. So on R1, we can show router BGP summary. You can see that we have a peering session to R2. So we can verify, we can check the BGP configuration, configure router BGP info. So these are the BGP configurations that are on R1. We have a group IBGP. We have defined the peer AS, the family, given it a description, and the neighbor. So we can run show router BGP routes. You will see that we don't have any routes on R1. We don't have any BGP routes on R1. So on R2, we can also verify that our configurations and the peering session are okay. So show router BGP summary. You can see that we have two peering sessions. We have one session to R1 and another session to R3. They are both established. We can show router BGP route. We can also verify that we are not distributing or exporting any route. We can run show router BGP neighbor. If we check, it's appearing to 1.1 and try to see whether we have some advertised routes. We don't have any advertised routes. Do we have any received routes? Received routes, we don't have any received routes. On R1 we can also do the same. Show router BGP neighbor. This one has a neighboring session to 2. Advertised routes, we don't have any advertised routes. We can check the received route. We don't have any received routes, which means we don't have any route that are being exchanged through BGP. On R3, we can also verify show router BGP summary. We have two peering sessions, one to R4 and another one to R2. We can show router, we can check the configuration, configure router BGP info. So these are the configuration. We have two groups. We have a group eBGP and group IBGP. In group eBGP, we have one peering session. This one will be to R2. And then in group IBGP, we have one peering session to R4. So we can show router BGP neighbor. Maybe we verify that we are not getting any routes from the eBGP peers. From the eBGP peer. So we can check advertised routes. We are not advertising any routes. Received routes, we are not receiving any routes. So on R4, show router BGP summary. We have one peering session to R3. Show router BGP route. We don't have any route. Show router BGP neighbor 3.3 advertised routes, no advertised routes. We can also check the received routes if we are receiving any. we are not receiving any routes. And we can also verify our BGP configuration. Configure router BGP info. So these are the configurations for BGP. So we now need to see how we can export routes from router. We will be doing our configuration on router 2 so that the route will be advertised both to the iBGP and eBGP. And to be able to do this, we first need to create a prefix. So we'll be matching a specific prefix that we need to advertise into BGP, and then we need to create a route policy. And once we have created a policy, we can now use that policy in our BGP to export the routes from one router to the other through BGP. So the first thing that we'll do on R2, we'll create a loopback interface. So I will create router, so I will do configure router interface, and then I'll create just interface loopback 200. I will specify it to be a loopback interface info, and then I can assign an address of 200.200.200.200. Mask is 32 info. So we have created an interface. We can ping. Remember, it's a loopback interface, so we should be able to ping the interface. So once you have created a loopback interface, we can now advertise this IP. So we need to export. We need to export the connected or directly connected routes into BGP, but then we only need to filter this specific loopback 200 IP. So we will not be advertising everything. Remember, it's always recommended that you don't import or export everything when you are doing route import and export in BGP, because sometimes you may have so many routes and you don't need all of them to be advertised to the neighboring peer. So once you have created the loopback, so we can show router interface. You can see we have loopback 200. The next step of our configuration will be to now configure the prefix. So for us to configure prefix on Nokia, we need to go under the policy option. So I will configure router policy options. And in this policy option, you will always have to run the begin command so that it allows us to now make the configuration changes. And we also need to commit. This is the only step where we need to do a commit in a classic CLI. So we can do info. We don't have any configuration. I can specify a prefix list. So with this prefix list, we'll call it import loopback 200, and then we need to specify the prefix. So prefix is 200, 200, 200.200. It's 32. You can specify longer or exact. This is just exact, a mask of 32. So we can do info, exit, info again. So you can see that we have configured a prefix list to match the loopback IP of 200.200.200.200. So I can now configure the route policy. So I will do policy statement. On policy statement, we need to give a name. We will also call it import loopback 200. So we can do info. And then we need to create an entry. So I will create entry 10. And then we can do from protocol direct. So we are importing the direct routes. We can do info. So we can see that entry 10 from protocol direct. We can also run entry 10. Remember, we are only merging 200.200.200.200. So I will do entry 10 from prefix. We have a prefix list. The prefix list is, we need to give a name. So we need to give the name of import loopback 200 info. So we have merged the protocol. So we are importing from protocol direct, but then we are only limiting to this prefix list. which is import loopback 200. Once we have done this, we need to specify the action. So remember, we are in entry. We'll go back to entry 10 info. We need to specify the action. So the action is accept, exit, and then we can now say that so let me see this one. Entry 10, I need to exit info. So we have entry 10, the action is accept, and it's merging from protocol direct with this prefix list. Once we have done that, we can specify the default action of reject. So it will reject all the other prefixes that are learned on this router via direct. So I can do info. So this is our complete prefix, our complete route policy. And now, once we have configured the route policy, the next step will be to use it under BGP. So remember BGP. So for one thing, we need to commit. I was forgetting to commit. Once we have committed, I can exit. Let's show info again so that we have the prefix list and the route policy. Then we'll go under BGP, configure router, BGP info. We don't have any export. So what I will do, I will specify export. So on R1, let's run again, show router, show BGP routes. We don't have any route. So when we do this on R2, we expect now to have these 200.200.200 advertised to the all other routers. So I will do export. And then we need to specify the policy. So it is import loopback 200 info. So we can check on R1, or we can first start by verifying on this router. So show router BGP neighbor it's 1.1. We can see advertised routes. So we have an advertised routes now. 200.200.200 is being sent to is being advertised to the neighbor. So on R1, we can show router BGP routes. You can see that we now have a route learned via BGP. We can check the details of this route. 200.200.200.200 detail. So we have the detailed information about this route. The network is 200.200.200, its mask is 32. Next hop is the loopback IP of router 2. And then we have learned it from router 2. Path ID, remember this is IBGP, so we are not attaching the AS path. So this is why we have no AS path. It's set to nil when a route is generated from IBGP and it is advertised to an IBGP peer. So we can check on R3. On R3, show router BGP routes. We have the route, and you can see this one is coming with the AS path. And then on R4, show router BGP routes. We have this IP. The prefix has been learned via BGP. We can try to ping 200.200.200.200. We should not be able to ping because remember, this is the next hop. The next hop is still set to 10.10.10.2. So we need to set it to, like when R3 is advertising the route to R4, it should set it to the next hop self or local. So yeah, this is how you do export of routes in BGP. We'll just again verify the configure router BGP info. This is how we do it. We have the export policy and used this policy that we have configured. Exit, configure router, policy options, info. We have this prefix and this route policy that we have configured so that we are able to advertise this route to BGP peers. So guys, this is how simple it is to export routes through BGP on Nokia routing devices. I hope you have enjoyed the session. And if you have any question, feel free to leave it in our comment section. And if you haven't subscribed to our channel, kindly subscribe to our channel and keep supporting our channel. Thank you.